Welcome back, everybody. Here we're going to take a look at hydrates. All right. So, if you just think a basic definition of the term hydrate, if you're hydrated, you think water. So, if you're dehydrated, you have lost water, or you have less water, or no water, right? Or you think less water, no water, dehydrated. But if you're hydrated, you have water. You're holding on to some water. So, if we use that basic knowledge, then obviously a hydrate would be something that has water. So this very first sentence here, it is basically telling us what a hydrate is, right? It's essentially telling us, so you've got a salt, we know what salts are, right? Salts, your ionic compounds, you've got metals and non-metals chemically bound together in some sort of form, forming those crystals, right? Those crystal lattice structures. So as some salts crystallize from a water solution, so obviously with water, they're binding together in the crystals. So you've got these crystals, and in the spaces in between, you get some bonding that occurs, some attraction that occurs with the hydrogen and the oxygen that's there, particularly these hydrogen type bondings. And because remember, water is polar, right? And so you're dealing with an ionic compound that has some polarity to it, right? Because you got cations and anions. There's this attraction that pulls that water in and kind of holds on to it, and it chemically binds it together. So depending on the spaces that exist in those crystal structures that form, you learn that in your basic chemistry stuff, depends on how much water can actually be held there, right? So it's a different ratio, but it's still moles of water. We're still looking at moles. Everything is about moles. When you're dealing with the compound formula, we're always talking about moles. Always. So let's take an example and let's do some stuff with it. So we've got sodium carbonate. All right. So we don't even have to read the rest of the problem. Obviously, we would need to know the formula for sodium carbonate, and we do remember, oh wow, that's really bad. We do remember that sodium carbonate, Na2CO3. All right, you should know how to write the formulas easy. If you forget how to do that, you need to research and look at some notes that I've given you, some videos, and write those formulas. So, sodium carbonate forms a hydrate, which means it's got water attached to it, in which 10 water molecules are present for every formula unit of the sodium carbonate. So let's think what it's talking about here. It's saying that there's 10 waters for every formula unit. So formula unit, the unit of the formula. I know that sounds weird to just, like I'm repeating myself, but what that means essentially is for every one unit that you have of this, you have 10 of these. So what that means is for every one of these, there are 10 water molecules. And the way we write that is we write the ionic formula, we put a dot, and then we have 10 water molecules. And that would be how you would write the formula for this particular hydrate. You write the ionic substance part, you write that formula, you put a dot, and then you put how many moles of water you have. So according to this, there's 10 of these for every one of those. They are chemically bound and attached together. All right. So let's name this real quick. We know that this is sodium. Wow, that looks like an O. We know that this is sodium carbonate. Okay. But it's just not straight sodium carbonate. It's got water on it. So sodium carbonate, remember the prefix for 10? Deca. Very good. And it's hydrated, so we would say decahydrate. So that would be the name of this particular substance. Sodium carbonate decahydrate. Pretty easy. So no matter what you've got, first thing you do is you always name the ionic part of the substance. As you learn, like your type, I don't care if it's type 1 or type 2, it doesn't matter. You name it according to those type 1 and type 2 rules. And then you use the prefix that you've learned, mono, di, tri, tetra, blah, 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 all that stuff, and to say how many moles of water you have, right? And so you're typically going to be dealing with ionic substances, the ones that we're going to be working with. Usually, you're going to have an integer that's 10 or less. But there are hydrates where it's greater than 10. And when we get to that, we just look at the prefixes that we need for those, and I'll give you those in class as we know. We don't need it for this, all right? Or in a video, I'll give it to you in a video. I'll do some sort of video at some other date with that, right? So right here, this thing says find the mass percentage of water in this compound. So no matter what your sample size, we've talked about this before in class and in these videos, you could have a sample size that's that big or that big. It doesn't matter. The ratio of what you got is the same. So there's always going to be 1 sodium carbonate for every 10 water molecules. So there will always be 1 mole of sodium carbonate for every 10 moles of water. So let's write this down. We know that we have 10 moles of water. Now this right here it says find the mass percentage. So that means we're going to have to take moles and we're going to have to go backwards. Not backwards, but we're going to have to just basically convert it from a mole unit into a mass unit, right? So what do? You use molar mass. All right, and at this point you should have molar mass for this stuff pretty much memorized, right? So 1 mole of water. You should know that, 16 right here, 2.02, so that means you get 18.02 grams of water. Let's cancel out those units. Remember, it's always about the unit. It is always about the unit. Now, I know a whole bunch of you are going to reach for your calculator for this, but 18 times 10 is 180, right? So you should see from this that you would get 180.2, right? But if you don't believe me, because I know that there are those of you who like to do this, I'll 18.02, 180.2. Okay. So we get 180.2, and we typically carry that second decimal place because that's what we're working with when we're dealing with our mass units of the periodic table, right? 20, and then that would be grams of water. Okay. Percentage means fraction of the whole. So we need to know the whole amount of mass that we're working with, which means we have 1 mole of sodium carbonate. So in 1 mole of sodium carbonate, how much mass do we have? Well, we know sodium is 22.99, right? So, if you don't remember you go back here, sodium 22.990, we're going to use 22.99, right? Carbon, you should have it memorized right now, 12.01, oxygen 16, right? So we've got 22.99 times 2 plus 12.01 plus 16 times 3, oops, not 16 times parentheses, times 3 parentheses. You should get 105.99. Okay? You should get 105.99. So that's 105.99 grams of sodium carbonate. All right. It's all about getting rid of those units. It's all about getting rid of the units. All right. So essentially it's 1 times 105.99 divided by 1. So essentially you've got 105.99 grams of sodium carbonate, right? So if you add both of these together, right? So I've already got the 105.99 in the calculator, so plus 180.2, you should get 286.19. Okay, 286.19, right? 186.19, and then that would be the mass of the entire hydrate. Okay, so now find the mass percentage. So to get any kind of percentage, your denominator has to represent the whole amount. Your numerator has to represent the portion in which you're looking at, right? So let me move this up a little bit. Give us a little bit of space here. So the percent mass of water. And it's always good. I know it seems like extra work, but it's always good. Your math teachers have taught you this for a reason. When you're doing stuff, define what you're talking about. Write it down, equals, and whatever it is. You're basically creating equations and formulas with everything that you do. It's just that when you're dealing with math, it always boils back down to algebra. So, mass percentage of water. So the water we see was 180.20 grams. And then the total mass, so the denominator always has to be the total amount, is 286.19 grams. All right? It's all about getting rid of those units, right? So you should think back whenever you're dealing with a percentage, you have to have your fraction. This is going to give us a decimal, so you'd always multiply by 100 to turn it into a percentage, right? So now we have 180.2 divided by 286.19. So times 100, you should see that we get 62.965, right? So we get, what is it? 60. We get 62.9651. Remember, just write some extra numbers. That's percentage. So we see 62.96%. Okay. 62.96%. That's what you should get. It's pretty easy. So, there's our answer right there. All right, so again, recap. You're dealing with a percentage, you're dealing with a fraction, and so right here it was just talking about when we write your hydrate, you are looking at the ratio of moles of the salt, that's the ionic compound, to moles of water. We did that, looked at how to name it. Just use your prefixes that we've already learned in class, plus they're on your reference sheet in case you forget them. And then using what we know about basic fractions and percentages. Percentage is a decimal is a fraction, which means a part of the whole. We use that to convert moles into mass, and then we looked at the ratio of masses, and that gives us this. So now, how would you use something like this? So I'm just gonna make something up here. So let's say we have a 3 gram sample of sodium carbonate decahydrate. I'm just making this up. I could have picked 300 grams. It wouldn't make a difference, but I would go with 300 grams when we can go with that. So, I'm looking at the problem that I just sort of made up here. So let's think about this. So you've got a 3 gram sample. If you've got something with water, how could you get rid of the water? You heat it up, right? So let's think about this. You've got a sample. And inside this sample is 3 grams of substance. You're going to heat it up. You're going to add in some heat. Well, let's think about it. The heat, when you heat something up enough, water goes into a vapor phase and it goes away. And in chemistry, we say that water evolved off. It came from here and it evolved off, right? That's how we say that. So it's going to break down into the salt plus water. Okay, so you've got your hydrate that you put in here. You're going to heat it up. That's the basic equation of what happens. So let's think about this. So we've got Na2CO3, put a little dot, 10H2O. We add some heat, and we evolve off the water, and we're left with the sodium carbonate plus we have 10 moles of water. We're going to assume theoretically that it's 100% efficient, that we get all the water off, right? And in class, in lab, we do this type of stuff. Well, I'll give you a salt. I'll give you a hydrate. You're not going to know exactly. You'll know the basics, but you won't know how many moles of water you have. You're basically going to have to decompose it. If you think about it, this is a basic decomposition reaction. You've got one substance. We're adding some heat, and we're decomposing it into its parts. We're into its components, right? Right. This is basically a partial decomposition reaction. That's what you do with these hydrates. The first set of heat basically drives off the water. All right. Now, this problem here says we've got 3 grams of this substance. So if we were to heat this off, how many grams of water could we get? We could always also ask ourselves, how many grams of this could we get, right? Well, there's a couple ways to do this. One, do what most people have done and how they figured it out, and what you're going to be doing in class is you literally would get this substance, you would apply some heat, and you would literally see steam start to form. You would see it bubble. You would see the water form very quickly, and then you would literally see gas vapor, water vapor going off into the atmosphere. That would be the water in a superheated state, in its gaseous state. Okay, so now let's think about this. Right now we're just doing theoretical stuff. So theoretically, we've already figured out that I don't care if you have a sample, remember, that is that much, it doesn't matter. According to this math here that we've just done, according to this, 62.96% of all of that mass is water. Water, it has a lot of mass. If you remember back from what you've studied in basic chemistry, it has a high specific heat. It has a lot of mass, and it holds onto that heat. So the more mass you have, the more heat it holds. So it takes more heat to actually drive that amount of water off. And that's some thermochemistry stuff that we'll look at a later time. All right, so let's think about this. We know that in this 3 gram sample, it's 62.96%. So 62.96% of this sample would be that mass right there. All right. So let's think about this for a second. So the mass of water would have to be the 3 grams that we have times 62.96%, which would be 3 grams times 0.6296. All right, so take our calculator. 3 times 0.6296. You should get 1.88888. Bunch of 8s repeating, right? Not a bunch. We have exactly 4 8s, right? So 1.8888, and then of course that would be grams. So 1.89 grams. 1.89 grams. All right. So now let's think about this for a second. If this right here, if we now can say that we've calculated this out to be 1.89 grams, can we figure out how many grams this is? Well, this right here, it would be, there's a couple things we can do. We can do basic mass by difference, right? So mass by difference, if you've got 3 grams here, you essentially have a problem where you've got 3 grams equals X. In this case, X is the mass of your sodium carbonate, right? So instead of just writing X, let's be specific. Plus 1.89 grams. Let's do some basic algebra at this point. So mass of the sodium carbonate, my brain stopped for a second, would obviously be 3 grams minus 1.89 grams, right? So 3 minus 1.89, 1.11. Okay, 1.11 grams. So now we can figure out, now we know, yeah, 1.11 grams. All right, so that's it. That right there, that's easy math. So the question is, are our percentages correct? Is this accurate? Does using 62.96 actually give us a value that is meaningful, that is accurate, and will affect the precision of what we do in lab? We can check our work. And in chemistry, the way you check your work, you got it, use stoichiometry. So let's think about this. We've got a 3-gram sample of sodium carbonate. Oh, I'm sorry, of sodium carbonate decahydrate. We already figured out the molar mass for this. If you think about it, 286.19, that's the molar mass of that hydrate. So we've got 286, I'm just looking at my notes, I've already got the calculation, 286.19, and I still want to have to scroll back up, grams of Na2, CO3, dot 10 water, and that's for every 1 mole of this substance. Now I'm going to run out of room, so okay, I'll write it. I would get on you for not writing it, so I'll write it. That's fine. Okay, I don't want to be a hypocrite. Na2CO3 dot 10 H2O. Luckily, I have some digital power here, and what I can do is select it. I can make it a little bit smaller. I know, it's cheating, but it works. So keep that in mind. If you have a lot to do, write smaller. If I were turning this in for a test, I would have already written smaller anyway. So times this. So now let's think about this. Grams of this substance on top, grams of this substance on the bottom. That whole unit's gone. Stoichiometry stuff works. Gonna have to write that whole thing again. Okay, now in this reaction, we see that there's 1 mole of this for every 10 moles of water, right? So we see that there's 1 mole of sodium carbonate decahydrate for every 10 moles of water. All right, let's get rid of those units. All right, so now 1 mole of water, we already know it has 18.02 grams of water. Get rid of that unit. That unit's gone. All right. Let's jump on in here. So we've got 18.02 times 10 times 3, 540.6. Check my math. Let's divide that by 286. Now, hang on a second. Let's think about this for a second. 286. If we round it up to 300, 300 times 2 is 600. Okay. The difference between 286 and 300, so we start thinking, wait a minute, it's not quite twice the amount. It's going to be actually a fraction of that amount, right? It's going to be a fraction of that amount. It's going to be less than 2, but it's close to 2, because 286 is close to 300, right? 540, we're getting close to 600, so we realize we may have we may be onto something here. This might work out. So 540.6 divided by, we got 280, oops, I already had that in the calculator, 286.19, drum roll, 1.88895, blah, 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 blah. So we have, on here, we've got 1.8889. We don't need any more numbers. We're golden. We're golden because up here we figured out 1.89 with our calculations. Right there, look at that. And that 8's going to round that up. 1.89 grams of water. This stuff works. This stuff works. When you do the math correctly, it works. That's the beautiful part. When the math doesn't work, then you know something is wrong. When you punch numbers in a calculator, make sure you're always thinking, does this make sense? Don't ever say to me, don't ever say to your math teachers, well, the calculator, that's what it told me. The calculator tells you whatever you tell it to do. All right? It doesn't know anything. It knows whatever you tell it to do. So if you don't know what to tell it, it's going to tell you whatever you tell it to tell you. Well, that got kind of convoluted. All I'm saying is when we took 18 times 10 is 180 times 3, there was our 540. And of course we had the change, right? So 540. Well, that's not quite 600. 286 is not quite 300. So 600 divided by 300 would be 2. But since we have a number less than 600 and we have a number less than 300, we should get a value that is slightly less than 2. And we got 1.89. It works. Go back, watch this video. Hopefully this helped. Everything you're going to do in your problem sets is related to basically understanding things of this nature. So you've got stuff with hydrates. Go back, do those things. Remember your prefixes for naming how many moles of water you got, and you're good to go. Hope this helped. Talk to you soon. Be sure to rewind this. Also, give me one of those. Give me a thumbs up if you liked the video. If you didn't, just don't give me a thumbs up. You don't have to. But let me know.